Welcome back to The Explainer. Today, we're diving into something literally groundbreaking. We're mapping out India's vast geography, but forget mountains and rivers for a second. I want you to picture the Indian subcontinent as a colossal, finite battery. It's this massive, complex geological vault that's actively powering the lives, industries, and futures of over 1 billion people. We're unpacking the exact resources that form the bedrock of India's industrial development, pulling straight from our chapter on mineral and energy resources. It's a fascinating deep dive into what's right under our feet and how it keeps our world running. So, here's our game plan for today. We'll start with the building blocks, then move into mapping the wealth. After that, we'll look at the fossil fuel era, transition over to powering the future, and finally wrap things up with conserving our resources.
All right, let's jump straight into part 1, the building blocks.
Before we can really grasp the massive industries driving the economy, we gotta understand the Earth's ancient materials. Okay, let's dive into this textbook definition. A mineral is a natural substance of organic or inorganic origin with definite chemical and physical properties. I know, it sounds a bit heavy, right? But it basically just means these things aren't man-made. They've been cooking over massive geological epochs, they have a specific chemical recipe, and a totally predictable physical structure. And get this, the bulk of these valuable minerals in India are products of the pre-Paleozoic age, mostly tied to the metamorphic and igneous rocks down in peninsular India. Now, getting these building blocks out of the earth, it is no small feat. We're talking massive, heavy industrial operations with giant earth-moving machinery digging deep into the crust. And here's the catch. You have to remember that minerals have this inverse relationship between quality and quantity. The really high-quality stuff, yeah, it's incredibly rare. It takes mind-blowing engineering and just immense capital to extract these raw materials that eventually become everything from the wiring in your walls to the steel in your car. To make sense of all this geological chaos, minerals are essentially split into two main branches, metallic and non-metallic. It's a pretty brilliant way to organize it. Under the metallic branch, we get further divisions. And over on the non-metallic side, we find things like fuel minerals, coal and petroleum, along with other non-metallics like mica and limestone. It's basically a wonderfully organized family tree of the Earth's resources. Now, if we look closer at that metallic branch, there's a really crucial distinction. Ferrous versus non-ferrous. Ferrous simply means iron. So ferrous minerals like iron ore and manganese actually contain iron, and they provide that incredibly strong base for our huge metallurgical industries. And good news, India is extremely well placed with ferrous reserves. On the flip side, we have non-ferrous minerals. These don't have any iron content. Think of copper, which is absolutely indispensable for making electrical wires and motors, or bauxite, which is the ore we use to manufacture aluminum. Moving right along to part 2, mapping the wealth. So now that we know what these building blocks are, where exactly do we find them? Well, India's mineral wealth is pretty neatly concentrated into 3 broad belts. First up, the Northeastern Plateau region, which covers Jharkhand, Odisha, and West Bengal. This is literally the jackpot belt. It's got iron ore and coal sitting right next to each other, which is exactly why massive iron and steel industries set up shop there. Second is the Southwestern Plateau region across Karnataka and Goa. It's packed with high-grade iron ore and bauxite, but it critically lacks coal deposits, well, except for Ney Valley lignite. And finally, the Northwestern region along the Aravalli in Rajasthan and Gujarat, which is known for copper, zinc, building stones, and Gujarat's petroleum deposits. And this brilliantly illustrates a key point. When it comes to metallic, specifically ferrous minerals, the wealth is highly concentrated. They're heavily clustered right there in the eastern and southern peninsular plateaus, while the vast alluvial tracts of North India are pretty much empty when it comes to economic minerals. Geography literally dictates destiny when we're talking about resource wealth. That brings us to part 3, the fossil fuel era. But look, building materials are really only half the story. To run an economy, you need power. We're talking about the heavy, conventional, exhaustible fuels that have historically been the engine of India's massive growth. And in India, power means coal. It's a vital mineral fuel used mostly for generating thermal power and smelting iron ore. Get ready for a staggering statistic. 80% of India's coal deposits are of the bituminous type, specifically the non-coking grade. The vast majority of these absolutely crucial reserves are concentrated in the Damodar Valley, sitting right in the Jharkhand-Bengal coal belt in famous fields like Jairia, which is the biggest, and Raniganj. Right alongside coal, we have crude petroleum. People often call it liquid gold, and for good reason. It's scarce, and its uses are incredibly diverse. from fueling our cars to manufacturing cosmetics and even synthetic rubber. Its history in India is actually super fascinating. Back in the day, Digboi, Assam was literally the only oil-producing region in the entire country. But things totally shifted after 1956. We pushed offshore to Mumbai High in 1973, and today we've got new exploratory wells tapping into deep reserves in the Krishna Godavari and Kaveri basins over on the East Coast.
All right, time to switch gears for part 4, powering the future.
Here's the reality check, though. Coal and oil are finite. They will, without a doubt, run out eventually. So we're at this pivotal moment where we have to look at tomorrow's solutions. On one side, you've got our conventional, exhaustible resources: coal, petroleum, natural gas, even nuclear energy. They rely on raw materials that just can't be quickly replenished. But on the flip side, we have sustainable, renewable resources: solar, wind, hydro, geothermal, and biomass. Not only are these sources inexhaustible, but they're also way more equitably distributed across the geography, and they are so much kinder to the environment. Plus, once you get past that initial setup cost, they give us sustained, cheaper energy in the long run. And what's really exciting is that India's already ingeniously tapping into these local environments to generate power. For instance, when magma from the Earth's interior releases tremendous heat, we can capture that geothermal energy, like at the plant commissioned up in Madikara in Himachal Pradesh. We also have massive, largely untapped tidal wave potential all along our huge west coast. Down in Okla, Delhi, there's an awesome bioenergy project actively processing municipal waste and garbage to produce energy which reduces pollution while keeping the lights on. And wind energy, it's an absolutely pollution-free source converting kinetic energy right through turbines, and it's expanding rapidly across places with favorable winds like Rajasthan, Gujarat, and Maharashtra. And hey, if you're looking for a mathematically proven reason to embrace this shift, just look at solar power. Sun rays tapped via photovoltaic cells or solar thermal technology aren't just clean, they are insanely efficient. In fact, solar energy is 7% more effective than coal or oil-based plants. It's actually a full 10% more effective than nuclear plants. When you consider the massive potential in western parts of India, like Gujarat and Rajasthan, going solar is a highly advantageous, cost-competitive path forward. Let's bring things home with part 5, conserving our resources. We really need to bring this narrative back down to earth for a minute and focus on the urgent need for sustainable development. The big question is, how do we actually balance our drive for economic growth with real environmental concerns? While our source material outlines some crystal clear, actionable strategies. First, like we just discussed, we need to aggressively shift to those inexhaustible alternative energy sources, solar and wind, to swap out fossil fuels. Second, for metallic minerals, we have to use scrap to enable metal recycling. This is an absolute must for India's scarce metals like copper, lead, and zinc. And third, we need to get creative. We have to innovate and find substitutes for these scarce metals so we can stretch our existing reserves for as long as humanly possible. I want to pause on this incredibly powerful quote straight from our source text about mineral resources. It simply says, they do not have the second crop. I mean, that perfectly hits the nail on the head, doesn't it? It captures the harsh reality. Minerals take long, incredibly slow geological ages to develop. Once we extract and use them up, they can't just be magically replenished when we need more. You can't plant a seed and harvest a fresh crop of iron ore or coal next spring. They are absolutely exhaustible, and we have to treat them with respect, conserving them rather than misusing them. Which brings us to our final thought. We do not get a second crop of minerals. The Earth's battery only holds a finite charge when it comes to these conventional resources. Just understanding this geography, understanding this stark reality, well, that's the very first step towards sustainable development. So I want to leave you with something to really chew on. As we transition into an era that absolutely demands sustainable solutions, how will you help power the future? Thanks so much for joining me on this explainer, and keep learning.